Today's lesson is on composite figures. These are notes for section 8.2. And go ahead and open those notes, and in the first blank write composite figure. A composite figure is made up of triangles, squares, rectangles, semicircles, and other two-dimensional figures. So here are two examples. This first one, the green or the blue one here, is made up of a square and a triangle. And the orange one is made up of a rectangle and a semicircle, which is half a circle. And today we're going to be looking at finding the perimeter of composite figures, which just means the distance around the figure. And to kind of help us keep an idea of this, we're going to look at a little activity. Whoops, wrong direction. Okay, so on your notes, you should see these two fences. A rancher is constructing a rectangular corral and a trapezoidal corral. So as you'll notice, there's a rectangle here that's 70 by 70, and a trapezoid with the top 50 and the bottom 74 and the sides of 70 and 74. We want to figure out how much fencing the rancher needs to construct both corrals. You could go ahead and figure that out and then turn your notes back on. Okay, for this first one, for the rectangle, he would need to add up. Both sides would be 70 and the top and bottom would be 74. And so you would go ahead and add each of those together. 70 plus 70 is 140. And then you're going to add your 74 plus your 74. And you should come up with 288 yards. For the trapezoid, you have two sides that are 74. And then you have a 50 side, and you have a 70 side, and when you add those all up, you should get, let's see here, 50 plus 70 plus... Looks like you get 268. So now, if he wants to build both of those, he's going to need to add the 268 plus the 288 to find a grand total of 556 yards of fencing. So to go all the way around both of those, that's a lot of fencing yards. Well, another rancher is building one corral, and he's combining the two corrals above. So on part B, here's these two corrals, and he has combined them or put these together. Does this rancher need more or less fencing? And we would say he would need less because, look, he doesn't need any of these fences that were in the inside. So it says how much less does he need? So we would not need this 70-yard side or this 70-yard side. So if we subtract 70 plus 70 is 140. So if we subtract 140 from our 556, we get 416 yards. So now this rancher only needs 416 yards. So he can save a lot of money. He does not need as much fence. So write down 416 for part B. And then let's look at part C. Part C says, is there any other way, well, I'm going the wrong direction here, that we could combine these two pins and use even less fencing? So we combined the 70s before. Think of a different way you might be able to combine it, and write that down and then turn it back on. Okay, one way you may have noticed is if you could take, up on top here we have one that's 74, and on the bottom we have one that's 74. And if we combine those, if I were to bring this one down here, if you were to combine these two fences, we wouldn't need them. And now that would take off 74 yards instead of 70 yards on each of them. And it's going to save us 8 more yards of fencing, which is a lot of fencing. It's going to save a lot of money. So as we talk today about composite figures and finding the perimeter of composite figures, you're going to want to find the distance it is all the way around the figure, not going through it, just all the way around the figure. So here's the first one that we're going to look at. This one's not on your notes, so if you'll look up here, to estimate, if you have it on graph paper, you're going to count the grids. Well, that's pretty easy on the straight sides. 1, 2, 3, 4. This one's 4 long. On the bottom, 1, 2, 3, 4, 5, 6. And again, 6 on the top. And then this is 2, and this is 2. But the part that gets tricky are these diagonals. Now let's look at a square for a moment. If you look at a square, if you were to draw a diagonal through the square, that diagonal is actually much longer. If I were to bring that diagonal out to the side, it's going to come up out about here somewhere. So diagonals are longer than edges. So when I go on my diagonal on this arrow, I can't count each of these as one. They actually wind up being, if you look on the square, they're actually almost 1.5 times bigger. So on diagonals, count how many diagonals, 1, 2, 3, 4, and then multiply that by 1.5. And 1.5 times 4 is 6. So this side's going to be 6, and this side's 6, because we have diagonals up there. So now we would add them all up. We've got 6, 1, 2, 3, 4 times. So 6 times 4 is 24, plus 4 more is 28. 29, 30, 31, 32. So you would say that this is 32 units around this figure. We don't know the units, so we just write units. So now look at your notes, and you have to pause this video and figure out the perimeter of each of these, and then turn it on and check your work. Okay, the first one, you should have counted on the bottom. 1, 2, 3, 4, 5, 6, 7. There's 7. If you're going to put a fence, it'd have to go all the way to 7 on this side, and 7 on the top. And then we have diagonals. So if we look at our diagonals, we're going to count 1, 2, 3 diagonals. So 3 times 1.5 is actually 4.5. And so this one's going to be 4.5. This is a 3 diagonal, so it's 4.5. And this 4.5. When you add those up, this side becomes 9, and the left and right both become 9, so that's 18. The top and bottom, 7 plus 7 is 14, so that adds up to 32 as well. So we would say units. Okay, let's check the green one. So we should have counted along the bottom. 1, 2, 3, 4, 5. I'm having a hard time getting my pen to stay straight with it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 along the bottom. 1, 2, 3, 4, 5, 6, 7, 8 along the top. 1, 2, 3, 4, 5. 1, 2, 3. And then we've got these diagonals. 1, 2, 3, 4, 5. So 5 times 1.5 is going to be 7.5. And you should have added each of these up. 10 plus 8 is 18. Plus 5 is 23, plus 3 is 26. So we have 26, and we're adding 7.5 to that, which should give you 33.5 units. So that's how you find the perimeter when you're estimating. So now we want to look at figuring it out if we're not estimating, but finding an exact number. So the perimeter means the distance all the way around. So I know the distance of this side, it's 8, and the distance of this side, it's 6. And the only other distance I need is this big curve, which you'll notice is a semicircle. It's half a circle. So we're going to find circumference. Circumference equals diameter times pi. And I know my diameter, they've got it dotted in here for us, at 10. So it's 10 times pi. And 10 is 3.14. So 10 times 3.14 is 31.4. Now that would be an entire circle, but we only have half a circle. So you're going to cut this number in half. So in your calculators, take 31.4 and divide it by 2, and you come up with 15.7. So that means that this arc right here is 15.7. So once you figure out each of the measurements, the last step, remember we're trying to figure out how to find the fencing to go around it. So I would need fencing here. I need all 8 feet of this, and this 6 feet, and this 15.7. I don't need to put a fence in here, so I don't count that 10 feet. So 8 plus 6 is 14. And I need to add a 15.7 to that, which gives me 29.7, and I do have units here. It's feet, so 29.7 feet. There are 2 on your paper. Actually, sorry, there's this one on your paper. This one is trying to find the distance around a track. So pause it, see if you can figure it out, and then turn it on to check your answer. Okay, on this one, we can already find out that each of the sides are 100. So I know that I'm going to add 100 here and 100 on this side. But now if you notice the top and bottom, if you were to put those together, you'd have an entire circle. And if my radius here is 32, then my diameter all across would be 64. So I'm dealing with a circle, if I bring it out here, that has a diameter of 64. And I can find circumference because it's diameter times pi. So 64 times 3.14 will give me my answer here for the distance around the top and the bottom together. And it's 200.96 would be my circumference. And I could cut it in half for top and bottom, but I don't need to because together they make a whole. So now I'm going to add my sides. One side of the track is 100, the other side is 100, so we'll add 200 to that. Come out with a total of 400.96, and if you round it to 401, that's fine. Meters, distance to go all the way around that running track. Okay, so now we want to look at these last two that you have on your notes. Take a moment in your groups and work those out, or if you're on your own, work it out on your own, and then let's look at them. Okay, this is like our first example. We know the distance of the bottom and the side, and we have half of a circle that has a diameter of 26. Circumference equals diameter times pi. So we're going to have 26 times 3.14. And if you multiply those out, you're going to have 81.64. And that was for an entire circle, but we only have a half a circle. So we're going to cut it in half. So divide it by 2, and we get 40.82. So this distance around here is 40.82. And we need to add that to our other two sides. Do not add inside. We don't add this 26. So I know that 24 plus 10 is 34, so I'm going to add that to my 40.82, and I get 74.82 centimeters for my perimeter of that shape. And finally, it says it is a square. And since it says it's a square, I can know that each of the sides are 8. So I already know 2 of my sides. And then again, I've got half a circle on one side, half a circle on another, so I'm really dealing with an entire circle with a diameter of 8. Circumference is diameter times pi. My diameter is 8, and pi is 3.14. So if you take 8 times 3.14, you're going to have 25.12, or 12 hundredths. We don't have to cut it in half because we have 2 parts of a circle, so I know that my 2 insides add up together to 25.12. And then I'm going to add my 2 sides. 8 plus 8 is 16. So I'm going to add 16 to that. And so we'll just go ahead and add that. And we know we can just add it all down. 12, 6 plus 5 is 11. So I have 41 and 12 hundredths. And we're dealing with meters here. So those are some examples of composite figures and how to discover the distance around them, or the perimeter. Your homework is a worksheet. It's the next page in your note packet. You need to do 3 through 17 odds and 20 through 24 all, and when you're done, do homework quiz 8.2. Now, your homework looks like this, and it should be circled. You just need to do the odds. Here on numbers 3 and 5 and 7, you're estimating. On number 5, you do have a half a circle right here, but you're just estimating, so kind of estimate how many lines it would take to go around it, like that, and you should be fine there. Number 9 and 11, you're just adding up the distance around it, so figure out the length of each side and add them up. Number 13 and 15, you've got some half circles in there you're dealing with. Number 17, we're not going to do, so go ahead and just cross that one off. And then you do need to do 20 through 24. These ones are order of operation. Please excuse my dear Aunt Sally. So that should help you work through those. When you're done, you can check your work.